everybody, this is Miss Phoebus and this is lesson 20, Transformation of Functions. I hope you have some paper and a pencil ready because I am going to show you some pictures and I want you to write down the functions that you see as well as their equations. So here we go. Number 1, do you know your function families yet? So number 1 here is the graph of a function family. Can you tell me the family name and the parent equation? Pause the video and write that down. Now, if you don't know this and you went and peeked at your notes, okay, but you do need to start getting them into your head and memorizing these. So the family name is that this is the square root family. And the parent equation, we're going to talk about the difference between our parent equations and our child equations. But your parent equation is y equals the square root of x. Here is number 2. Pause the video, write down the family name and the parent equation. All right, this is the linear function family. Its parent equation is y equals x. Here is graph number 3. Write down the family name and the parent equation. Pause the video. This is the cubic root function family. The parent equation is y equals the cubic root of x. Here is the 4th function family. Pause the video. This is the cubic function family, y equals x cubed. All right, here is your 5th function family. Its family name is the constant function family, and its parent equation is y equals a number, and in this case we're using c to represent that number. All right, number 6. This function family is the exponential function family. Y equals b to the x, or you could even have y equals ab to the x. On any of these, if you have f of x equals, that's fine. That's the same thing. All right, let's look at 7. What is the family name? This is the quadratic family, and they are y equals x squared. And then number 8, what function family is this? All right, this function family is the absolute value function family, and its equation, parent equation, is y equals the absolute value of x. How did it go? Hopefully it's getting better. It's getting easier for you. You're recognizing the shapes of the graph. You're recognizing the names. You're recognizing the equations, what they have in them. We're going to use that skill today. All right, now here's 9, 10, and 11. Based off of the equation, can you tell what the function families are? So I'm going to have you pause the video, see if you can figure out 9, 10, 11, and 12. All right, you're back. 9 is the cubic function family. 10 is the quadratic function family. 11 is the absolute value function family, and 12 is the cubic root function family. Now the goal for today is to be able to graph some of these with these extra numbers in them. Maybe not so much 9 and 10, but by the end of this lesson today, you should be able to graph something or at least know what the graph looks like for 11 and 12. All right, so let's get into today's lesson. Your goal is to be able to identify the effect of single or multiple transformations, what they will have, what effect they have on a function, an equation or a graph. And we're going to look at both of those. Your standard is this where you have to identify the effect of different things, replacing f of x with f of x plus k. That means we're adding something to the function. We're multiplying by k, multiplying a function by something, and then adding something inside with x So we're going to look at what all of those mean. Notice that this piece has been striked out because that is something that you cover in Algebra 2. We do not have to do that. But we're looking at specific values of k, both positive and negative. So we're going to be adding and subtracting as well. And then look at what did the graphs look like. We can experiment with technology, so you can go and plug things in a calculator. But we're going to really just kind of look at it by hand right now and what to expect. And I'm also going to link it to what I want in the homework. I don't want you to spend 47 years graphing these with lots and lots of points, so I'll show you what it looks like. All right, so let's get into our transformation of functions. So all these rules apply to every single function. Doesn't matter if it's exponential, it's quadratic, it's square root, it's linear, all of these things apply. Now with linear, there is a little bit of a difference, and we'll talk about that in a moment. But basically, a translation is a shift left or right and up or down, preserving the shape of a function. So you can have just a shift left or right, up or down, or you can have a combination of these as well. Okay, so your original function looks like y equals f of x. And what we're going to do is we're going to have two places where we plug things in. We have this minus h area, and we have this plus k area. So if you are inside hanging out with x, that is going to mean a left or a right shift. So inside hanging out with x, left or right. The plus k is kind of on the outside, kind of took like a step back from x. It's kind of there, but it's not involved heavily with x. And so this is a shift up or down. And where these numbers are in the equation is going to tell you what directions that you are moving. Now, notice that I have plus h, minus h, plus k, and minus k. Having an addition sign is different than having a subtraction sign. Now, inside where we are moving left or right, this is going to feel opposite of what we do on a number line. It just is how it is. So usually if this was a plus h on a number line, I would move to the right. If it was positive, you go to the right. But this means to shift left h units. So sometimes, and it's even me, I've been doing this for a long, long time. Sometimes I have to stop and think, okay, I see plus. I got to do the opposite of what I want to do. So don't feel bad if you have to pause and take a minute and think about it. All right, if I see a minus h, minus on a number line makes me think I need to move left. But this is the opposite. It feels opposite. So that means I'm going to be moving right h units. Now, what is h? It's a number. So if it was a minus 3, I would be moving right 3 units. Okay, so these are just representing some number value. Now, k is different. K makes sense. I'm going to write that. But basically, what I mean with that is if it's positive, you shift up. If it's negative, you shift down. So it makes sense to the sign that you have. Whereas the H doesn't really make sense. It's opposite. So you have to kind of think about it a little bit more. So with our plus K, that means we're going to move up K units. And with our minus K, we're going to move down K units. And hopefully you're writing all of this down so that you can use this on your test. All right, so we're going to look just at translations starting off, and then we'll get some other things we have to talk about, reflections and stretches and compressions. There's quite a bit that go into this. All right, so if you were in the classroom, I would be asking you what function family this was, and I would be wanting to hear from you, kind of like a shout it out. What do you guys think? So what function family is this? And if you said quadratic, you're correct. All right, so this is my parent function. Parent functions, just like parents, are boring, yet reliable. usually. Not always, but for the most part. So yeah, they are boring and they like to go to bed early. They're not living the exciting life, but they're usually there when you need them. So these guys are going to go through 0, 0. So that's kind of boring, but we can always depend on them being at 0, 0. Again, we have some function families like our exponential ones. They like to go a little crazy, so they're pretty reliable, though we can find them at 0, 1. So anyway, this is our parent function in blue. And we're going to now get what I like to call a child function. Now, it's not always called a child function, but I like to call it a child function because what goes with parents? Children. And children look an awful lot, most of the time, but they should look very similar to their children. Children look like parents. And so this red function looks an awful lot like the blue function, but there is a little bit of a difference. Just like you kind of look like your parents, but there's a little bit of a difference. Now, the question is, what is the change? So when we look at this, this has been shifted up. Okay, we did have our blue parent function at 0, 0, but now our red one, that same part of the function is now shifted up and it's at 0, 2. So we would say, for what is the change, that it's been moved or shifted. You could even say vertically shifted if you wanted to, but I like to go pretty basic. It's been moved up 2 units, or even just moved up 2. So what we're going to do with these children functions is they are going to be flipped and stretched and pulled and shifted left, right, up, down. And it's our job to figure out how that's going to happen. So we can tell from the graph that we have shifted the red one up 2. If I move it back down 2, I would be back at my parent function. All right, so the equations, the parent function are the ones that I have been trying to get into your head. So for my parent function here, I would have y equals x squared. With my child function, I now have to raise it up 2. So I am in this, where I'm dealing with y equals f of x plus h plus k. I think there might have been a minus in there before. But anyway, so if you notice, this is left and right, this is up and down, so I want to show up 2 in this area. And so how am I going to do that? When I write my child equation, I'm going to put a plus 2 at the end. So let's write y equals x squared plus 2. Now, here's where the technology is pretty helpful. Let me grab my calculator. Okay, so here on my calculator, I'm going to go to y equals, and I'm going to graph x squared as my parent function. So I should have something that goes through 0, 0. It's also going to be blue, so I'm going to compare it to what I have over here, and then I'm going to get my x squared plus 2. So then what you can do is you can compare, if you have a picture of the graph of the equation that you're trying to write, and you want to compare and see if it matches, this is one way to do that. So there's my equation. So I'm going to hit graph, and there's my parent right there. And then this one has been shifted up too as my child, and you can definitely see 1, that little marker for 1 in there, so we assume that it's hitting 2. And you could zoom in if you want, zoom 2, and then you have to hit enter. But you could zoom in and be able to see, yeah, it's going through 2. I'm going to hit zoom. I like zoom 6. That refocuses it. All right, so that means that our equation, x squared plus 2, is correct. And we also have the correct parent function. If I typed in the wrong parent function and I looked at the graph and the pictures didn't match, then I know that I need to change a few things. All right, so let's get back in and let's go look at another one. Okay, so what function family is this? If you said the square root family, you're correct. All right, so this is my parent. This is my child. What's the difference? How is the red one different than the blue one? If you said we took the blue one and moved it 1, 2, 3, 4 to the right, you would be exactly correct. Okay, so usually it's what change was made to the parent to get the child, not to go backwards. Okay, so what's the change? Now let's look at writing equations. So this is a square root function. So my parent function is y equals the square root of x. Now, when I go through, I'm going to write this y equals, let's do f of x minus h. I think that's the right way to do it. So I am moving left and right. That means that this piece has to be, a number has to be put in there. And so the question is, what type of number to show right for? So remember that minus h moves us right, and plus h moves us left. Well, we don't want to go left, we want to go right. So I'm going to make sure I'm putting in a minus 4 when I write this. Now, the number has to hang out with the x. So I'm going to have y equals the square root, and I'm going to extend my square root because I need to give it space because there's a number in here that's going to hang out with x. So to move it right 4, I'm going to subtract 4. Now it should feel backwards. It should feel opposite to you. Let's go and let's look at our calculator. Here we go. We're going to clear out what we have. And we're going to type in the square root of x. That's our parent function. And then the square root of x, and then minus 4. So I need to make sure that all of that is underneath my square root. So let's graph that. And if you see, here's my parent function in blue, here's my child function in red. Now, let's say we wrote our equation wrong. So let's say that we came down here and we did not write the minus 4. We got minus 4, but we didn't put it under the square root. We made the square root stop, and we just did minus 4. That means something different. Do you see how my pictures don't match? Do you see how, yeah, the blue one is the same, but instead of the red one being right 4, the red one has now been dropped 4. It's down 4. So there is a difference in where you place the numbers and how you place them. Let's say for a moment you did get it underneath the what we call the radical, but you got the number wrong, the sign wrong. It's not minus 4 like we know it should be, it's plus 4. Let's see what happens. So with a positive 4, it doesn't move you to the right, it moves you to the left. So you can play around with the graphing calculator and see if you can figure out the equation that way. It is a good idea, though, to learn how to read your equations because in the long run, you're going to be a little bit better off for that. And that's my goal for you, to be able to give you an equation and you to be able to read it. All right, now here is a linear function. And what we're going to do is we're going to look at a change in our linear function. Now, linear functions, they are, and this goes with constant functions as well, when you talk about change in a linear function, I only want you to talk about up and down. That's the only change I want you to talk about. Do not talk about left and right. It gets confusing. You have to change signs. Only talk about up and down with linear functions. Okay, so if I compare the red function to the blue function, it looks like I took the blue one and dropped it down 1, 2, 3. I want to make sure that I know the distance between the point right above and the point below. Now, what happens if I come up here to, what is that, 4, 4? And I drop that down 3. 1, 2, 3. I'm still on that function in the same spot. So this is going to be every single move that I have made with this blue function is going to be down 3 to create that red function. Okay, so it's not just sometimes, it's always. So because we're dropping 3, we're going to say it's been moved down 3 units. So let's look at the parent function, and this goes into writing your equations with the up and down. That's going to make things a little bit easier. So y equals x is your parent function. Now if you remember your linear functions from middle school, you could say, well, y equals mx plus b, and that's great. But y equals x, how do you show that you were dropping, moving down 3? Subtract 3 from that. Now when you're doing that, it's almost like x is kind of by itself, that minus 3 is doing something else. So I'd rather you think about, just for linear functions, up and down only instead of left and right. All right, what function family does this belong to? That's right, it's the absolute value function family. All right, let's get our child function in there. All right, I had to draw the child function because for some reason it's missing, but it's not the best picture, but hopefully you can detect that there are changes, not just a change. So if you notice, I usually go from the bottom of this V to the bottom of this V and I try to count. So it means I would go down 1, 2, 3, 4, 5. And then I also need to go left 1. So the change is it's been shifted down 5 and left 1. All right, let's look at our equations. So we have a parent equation of y equals the absolute value of x. And then my child function, let's go into what we had in our notes earlier. That means I have 2 numbers in here. So I need to show down 5. Down is on the outside. So to make this down 5, I need to look at it as a minus 5. Remember, it makes sense. For the left 1, I need it to go inside, hanging out with x, so it's going to be inside the absolute value. And to go left 1, it's not minus 1, it's plus 1. So left 1, down 5, let's write an equation. Y equals absolute value of x. I need to show left 1, so hanging out with the x, there's a plus 1, and then outside shows down, so I'm going to have a minus 5. Let's look at that in the graphing calculator. Okay, so we're going to go in, we're going to clear out what we have. We're going to get our absolute values in there. So I'm going to have, if you hit the alpha and the window button, there's your abs. And we're going to put in the absolute value of x. And then we're going to do it again, alpha, window, abs. And we're going to have x plus 1. Now I have to get outside to put in my minus 5. If you put it inside, it's going to just do whatever 5 minus 1 is, which is negative 4. And then it's going to make that change. Minus 5. Watch out for negatives. We don't want any negatives right now. So here's our graph. And that kind of matches, right? We have our blue one at 0, 0. And then this one looks like it's been shifted left 1 and down 5. And there we have our graph. So you can use your graphing calculator on this. All right, so this is going to be like what's in your homework. So if you follow along with this, you're going to be able to do what's in the homework. My question to you, what function family does this function belong to? It has absolute value bars. It's in the absolute value function family. So that means its parent graph, parent equation is y equals the absolute value of x. Well, what does the shape of the graph look like? Well, if you remember, all absolute values look like V's. So it's a V that goes through 0, 0. Now notice that I plotted one point. The only point I plotted so far is 0, 0. You do not have to plot points for the arms, okay? I don't want this taking a whole lot of time. I want you to be able to graph these quickly. When we go back and we study absolute values a little bit closer, then we will be more precise with our graphing. So that is my parent function. In the homework, you have to identify what the parent function is. You don't have to write the equation, but you do have to graph. So on every single graph in the homework in this section, in this lesson 20 part, you have to have two functions, two graphs on your coordinate plane. All right, now the question is, what is this plus 5 doing? So I'm going to go back to y equals f of x minus h plus k. And I notice that we're dealing with something hanging out with x. So this means it's either left or right. Remember, it's backwards of how you feel. So I see a plus 5. Plus 5 makes me think positive 5 on the number line. That's to the right. But that's not what I want. I want opposite of that. So that means that this has been changed and shifted left 5 units. That is something that you have to do in your homework. If there's one number, there's going to be one change. If there are two numbers, there's two changes. So make sure if you notice that there are more than one number, you are writing down more than one change. Okay, so we know that it's been shifted left 5. So we're going to come back over and I'm going to change colors, and I recommend you do something like that, either highlight it after the fact, make it stand out, something like that. So what I'm going to do is I'm going to start here at 0, 0, and I'm going to move left 5. Now these little dots, those aren't really there. I'm just showing you that I'm counting. I'm going to go left 5, I'm going to put that point, and then I'm going to make the same arms that I did before, and that's what I want you to graph for your child function. Now, it is sometimes helpful if you come through and you say, this is my child, or my transform function, and this is my parent. Some people do better with labeling. Some people do better with colors. Something to make it stand out that there are two different functions there and that you know which one's which. All right, now when we do domain and range in your homework, it's going to be of the child, not of the parent. So we're going to focus on the red graph that I just did, and that's where the color kind of helps, makes it pop. So I'm going to go and look at the child. So how far left does this function go? It goes to negative infinity. How far right does this function go? It goes to positive infinity. How far down? Looks like the lowest y value, and you guys are getting confused with x and y values. This is range. So the lowest y value that I reach is 0, not negative 5. 0 is the lowest y value. How far up does it go? It goes to positive infinity. All right. So in your homework, you have to graph the parent function. You have to graph the child function. You have to tell me how the child has been changed and what the domain and the range of the child are. And you should have enough space for all of that. Okay, so let's do another one. What is the parent function? So if you notice, there is a squared here. We only have one function family that has an x squared in it, and that is the quadratic function family. The parent equation is y equals x squared. So when you're trying to determine what function family it lives in, you're looking for key things like, does it have a square root? Does it have a cubic root? Does it have something to the third power? Is the x in the exponent? Those types of things. Absolute value bars. So you're looking for specific features that the graph equation actually has. So what does the parent function of a quadratic look like? Well, it goes through 0, 0, and it's kind of U-shaped. That took 3 seconds. Okay, yeah, I know what it looks like, and I want you to know what it looks like, but it should not take you a long time. Okay, so I know it's quadratic because of the squared. Let's look at how it's been changed. So I see that there are two numbers, so there are two changes. Inside, hanging out with x, I see that this is going to be left or right. Outside, away from x, that's going to be up or down. So inside, hanging out with x, left or right, I see -3. I think -3 is on the left, but I want to go against all those feelings. This is right 3. So I'm going to come down here, right 3. And then up or down. So up or down makes sense. Looks like a +2. That means I'm going up 2. So that's how it's been changed from the parent function. So I'm going to draw this in red. I'm going to go right 3 and up 2. I'm going to start at 0, 0, right 3, up 2, put a point, and make another U shape. If I know what my parent looks like, then it's really easy to build my child. All right, let's look at domain and range. How far left does the red function go? -infinity. How far right does the red function go? +infinity. How far down does the red function go? Looks like the lowest y value is going to be 2. How far up does the red function go? +infinity. Make sure you know you're learning how to read the equation, what each piece means. The sign makes a difference, and where that number is located makes a difference. All right, so let's go back to the calculator. We're going to clear everything out. We're going to look and see if we are on the right track. So let's look at x squared, and then let's look at x minus 3 in our parentheses, and then we got a +2. Don't forget your little squared though, because if you lose the squared, you change the function family. Okay, so there's my blue one. Here's my red one. Looks like it's been shifted right 3, up 2. We're looking good. Our graph matches. So you can use the graphing calculator to help you out. And you have one on your Chromebook. If you don't know about it, please email me, let me know. I can help you find it. All right, so let's look at reflections. A reflection is a flip, usually upside down. You can do it across the y-axis, but all our class does is reflect over the x-axis. And how do you know you have a flip? If you get a negative in front of your function. That's how you know you got a flip. We flip for negatives. All right, so here is our parent function. This is the quadratic function family. And then here is my child function. And if you notice, it looks exactly like the blue function, except it's been flipped upside down. So it's reflected or flipped. I'm okay if you say flipped over the x-axis. Now we do want to say over the x-axis. I would like you to put that because there are other flips that you can make. Okay, so our parent function, y equals, this is quadratic, so this is x squared. And our child function would be y equals, just put a negative in front of it. And what that does is it takes whatever is being squared and makes it negative. All right, let's look at this on the calculator. I already got x squared in there. I'm going to clear that out, and I'm going to type in negative x squared. So I just put a negative in front of my x squared. Graph it, and there's my parent function, and there's my reflected or flipped function with a negative in front of it. So you want to flip something upside down? Throw a negative in front of it. Okay, so we have a transformed function with a negative in front. We can see that it is a cubic function because it's raised to the third power. So that means my equation, or my parent function, is y equals x cubed. I'm going to graph that and start at 0, 0. On the right side, it looks kind of like a quadratic. On the left side, it looks like we flipped it one upside down. So there is our cubic. And then we already know that this is reflected or flipped over the x-axis, what we're going to do is we're going to still be at 0, 0, but instead, for the right side going up, we're not going to go down. And instead of going down on the left side, we'll go up. Right child, right parent, you can use 2 different colors, something to make it pop. All right, let's look at domain. This is a cubic function, so it's going to go left and right forever, negative infinity to positive infinity, and then it's going to go down and up forever, negative infinity to positive infinity. The calculator, and equals dx to the third power, and negative x to the third power. We can check ourselves. Here we go. The red one is our child, blue one is our parent. Okay, and the last type of transformations that we're going to talk about are our stretches and compressions. We're going to deal with vertical stretches and compressions, and what that is we are going to take, it's almost like you take the function and you pull it from the top and the bottom. That would be a stretch. Or if you take your function and put your hands on the top and bottom of that function and squeeze it from the top and the bottom, that's a compression. So you're going to have a number in front of your function being multiplied times that function. So a stretch will make the function taller or narrower. So this does not preserve the shape of the function. The function shape will actually change a little bit. It'll look taller, it'll look narrower, and a will be a number greater than 1. A compression will make the function wider or shorter. It does not preserve the shape of the function. A will be between 0 and 1, so it'll probably be a fraction like 1/2, 1/3, something like that. Now you can't just say it'll be a fraction, because I could say something like 5/2. 5/2 is a fraction, but it's also greater than 1. So that would be a stretch. So you kind of have to watch out for the fraction piece. If you have a 1 in front, there is no stretch, there is no compression. So let's look at an example of this. So here is an absolute value function, and what has changed? So from the blue to the red, notice that the red has gotten wider. So because that is wider than my blue function, this is a vertical compression. It looks like somebody stepped on the blue function to make the red function. All right, so my parent function is y equals the absolute value of x. And then my child function, and we'll get into how do I know all of this stuff, but my child function is y equals 1/3 times the absolute value of x. So the 1/3 is out in front of my absolute value. 1/3 is between 0 and 1, so that makes it a compression. Let's stick with the absolute value family. And now, do you see how this one, the red one, is taller and skinnier? It is a vertical stretch. Y equals the absolute value of x. My child is y equals 3 absolute value of x. So that 3 is again out in front of my absolute value, but it is a number bigger than 1, so that makes it a vertical stretch. And all of these you can put in the calculator. You just have to make sure that the 3 is outside in front of. So we're going to look at graphing with a linear pattern. So we know that 5x is a linear, so its parent function is y equals x. And let's graph that parent function. So y equals x puts it at 0, 0. And it's a nice line there. And then we know that this 5 is bigger than 1, so it's going to be a vertical stretch. So what that is going to do is it's going to make it, in this case, it's going to make it steeper. It's not going to make it skinnier, really, because it's just a line. But it's still going to go through 0, 0, except now it is much steeper than what we had before. It doesn't affect the domain.
or the range. Remember, the domain and the range for our linear functions are negative infinity to positive infinity. So it's still going to apply for both of those. Let's try a different one. So what function family does this belong to? You see the absolute value bars and you said absolute value. You are correct. The parent function is y equals the absolute value of x. Absolute value function, parent function starts at 0, 0, and you make a v. Notice again, I'm not drawing a whole bunch of points. I'm just doing a basic shape. 1/4 is a number between 0 and 1. So that means that this is a vertical compression. Sometimes you'll see the word squeeze go along with it too. All right, so that means I'm still at 0, 0. That part doesn't change. And now I'm opening wider. Okay? So let's see how that affects the domain and the range. The domain, how far left? Negative infinity. How far right? Positive infinity. The range, how low does it go? Looks like a y value of 0, and it goes up to positive infinity.